Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to write formulas from names. And now this is going to be a mixed batch. So we could have ionic compounds or covalent compounds or acids. So we just have to look at the name we're given and try to translate that into a formula. So we're going to have to categorize these and notice what and kind of bring to our mind what sorts of characteristics are tied to the names of different substances in different categories. So remember, if you have an ionic substance, you're going to have a metal and a nonmetal. So do you have the name of a metal in the name of the compound? Or is there a Roman numeral, right? So if you see a Roman numeral, that means you have a metal and it's a transition element, which means that the Roman numeral is identifying the charge that's on the metal, which is helpful for writing the formula when you do the crisscross method, right? Are there Greek prefixes in the name? If there are, that could be identified as a covalent compound. That's a dead giveaway. Does the word acid is the word acid in the name? So that would identify acids, and then you have to figure out is it a oxyacid or is it a binary acid? And we got to remember that if it's a binary acid, you're going to have hydro in the name. If it's not, then you're not going to have hydro. So those are the things you want to kind of keep in the back of your mind and use to help you identify what category it is, and then write the formula based on that. Okay, so let's get into this. So we have ammonium nitrate. So right away, when you have ammonium nitrate, you should recognize these as the names of polyatomic ions. So obviously, this is going to be an ionic substance. So you write the formulas for the ions and you do your crisscross method to make sure that the charge balances so you have a neutral product. Remember, ionic substances are always neutral. So we write the formula for the ions. So we have ammonium, which is NH4 plus, and we have nitrate, NO3 minus. So you got to know the formulas and the charges of your polyatomic ions. If you don't, then go back and review your note cards. Okay, so here, if we do the crisscross method, there's one each, so we know that plus one and minus one are going to cancel each other out. So we only need one of each, right? So we can see that by the crisscross method too. If there's a one there, that's going to go down there. There's a one here, that's going to go down there. They're both ones, so we don't really write the ones. So this is just going to be NH4, NO3 for the formula. So there you go. That's the formula for A. B, acetic acid. Gee, I wonder what category that belongs in. So the acid gives it away. We're dealing with an acid. So is it binary or is it oxy? If it's binary, we would expect hydro to be the beginning of the name. We don't have hydro here, so it must be an oxyacid. So remember, the oxyacid name comes from a polyatomic ion name. All you do is drop the ending and add either AIC or OUS. If you have IC, that means that the polyatomic ion began with an 8 or ended with 8, because that's the rule. If it ends in 8, you drop the 8 ending and you add IC. Okay, so this has IC, so this comes from the acetate ion. So we write the acetate ion like so. That's going to be C2H3O2 minus. And since it's an acid, we have to add hydrogen to it. Now, the thing you want to keep in mind is that hydrogen tends to have a plus charge on it. So think of hydrogen as being H plus. It's not. It's an ion in solution, but as an acid, acids are not ionic compounds. They are covalent. But it's helpful to think. Excuse me. It's helpful to think of these as ions. So if I have a -1 charge here, then how many hydrogens do I need to cancel out that charge? So if H is an H plus, then I only need one H plus to cancel out the charge. So I add an H like so. I can get rid of the charge, and there's my formula for acetic acid or acetic acid. Excuse me. All right, now next we have sodium hydrogen sulfate. So again, we want to look at the name and see if we have a metal in there. And we do. Sodium is a metal, and hydrogen and sulfate, those are non-metals. So this is ionic. So we're going to need to figure out what the ions are. Well, since we know that this is the metal, that's the positive ion, which means that everything else must be part of the negative ion. Since we have hydrogen and sulfate, this is a polyatomic ion. So you just need to know your polyatomic ion formulas and charges. So sodium has a +1 charge because it's in group 1A. And next is the hydrogen sulfate. Hydrogen sulfate is going to be HSO4 minus. A way to remember this is that if you remember that the sulfate ion is SO4 with a 2 minus charge, right? So SO4 is a 2 minus charge. If you go back to remembering, okay, thinking of hydrogen as having a plus charge on it, you add that to the sulfate, and then you take away one of the negatives, that will give you hydrogen sulfate with just the negative on there. So again, that's kind of an easy way to help you remember those patterns. So now that we have our two formulas of our ions, you'll notice you have a +1 and a -1. So both of those will cancel each other out. So again, same idea. If we do the crisscross method, it's just going to end up 1 to 1. So we write the formula. It's going to be NaHSO4. So let me put a box around these so you remember. So that's the formula for that one. Potassium bromide. Again, is it ionic? Yes, because we have potassium, that's a metal. Bromine is a nonmetal. We have an ionic substance. So we're just going to write down the formulas of the ions. Potassium, again, that's K, and it has a 1 plus charge on it because it's in group 1. It'll lose 1 electron to be like the noble gas. Bromine or bromide is the bromine ion. So it has a -1 charge because, again, it's in group 7. It's going to gain 1 electron to be like its noble gas. So we write that Br minus. And again, we have a +1 and a -1. They're going to be canceling each other out 1 to 1. Again, you could do the crisscross method, 1 down here, 1 down here. But basically, you're just going to have 1 each. So that's going to balance the charge. So KBr is the formula for potassium bromide. Okay, next, E. We have magnesium hydrogen phosphate. Again, we want to see if we have a metal, and indeed we do. Magnesium is a metal. So this is going to be a hydrogen, this is going to be an ionic compound. So that means, once again, the first part is your metal. So that's the positive ion. That means that everything that follows is part of the negative ion. And so the fact that you have hydrogen phosphate again here indicates you got a polyatomic ion, and you have to know what the name and the formula and the charge is on your polyatomic ions. So we'll start by writing the ion of the magnesium metal. That's going to be Mg2 plus. It's got a 2 plus charge because it's in group 2. It's going to lose 2 electrons to be like its noble gas. And then next we have hydrogen phosphate. So again, to write the formula here, we can start with the phosphate. Oops. PO4, and it's got a 3 minus charge on it. So that's the phosphate ion, but it's hydrogen phosphate, so that means that we're going to have one hydrogen. If there were two hydrogens, it would say dihydrogen phosphate. But since there's only hydrogen, that means we have one hydrogen. So I'm going to add a hydrogen here. And remember, the hydrogen we can think of as having a +1 charge. So when we add a hydrogen with a +1 charge, that's going to cancel out one of the negatives, and that's going to bring that down to 2 minus. So we can do our crisscross method to figure out what the balance of charge is going to be. So we take the 2 as a subscript, we put a subscript there, and then we take this 2, write it as a subscript there. And so we can write the formula. Make sure I have enough room. I'll write it down here. So then now I have Mg2, and then because I have 2 of these hydrogen phosphates, I'm going to have parentheses, HPO4, 2. And then we got our formula, but you want to make sure that you double check the subscripts here. The subscript on the outside of the parentheses with the subscript here for magnesium to make sure that it's not reducible. If it is reducible, then you have to reduce it. And here it's a 2 to 2, so that's reducible to 1 to 1. So again, we have MgHPO4. So we'll erase this to give ourselves some room. So the final formula, excuse me, is MgHPO4. So I only need 1 each to balance the charge. Since this is a +2, this is a -2. Let me put a box around that. Next, we have hydrofluoric acid. So obviously this is an acid. We're going to name it like an acid. Is it an oxyacid or a binary acid? Remember, binary acids begin with hydro. This one begins with hydro, so it's a binary acid. So this acid is only going to be made up of hydrogen and some other element. The hydro identifies the hydrogen, so I'm going to have H there. And fluoric, remember how we got fluoric? We dropped the ending in at ICE, so the ending was fluorine, so we got F for fluorine. So if we think of this, we know if we think of this as ions, we know fluorine tends to have a -1 charge, hydrogen tends to have a +1 charge, so they balance each other out. So it's HF. Again, it's not an ionic substance, it's covalent. But again, it's useful to think of them as ions to help figure out, make sure you have the right formula. All right, next, and that's the formula for HF. And by the way, HF, hydrofluoric acid, is the acid that was used by Mr. White, aka Heisenberg, when they were dissolving the bodies, right? So if those Breaking Bad fans out there, this is the hydrofluoric acid that they were using. Very bad stuff. Very bad stuff. So I won't digress too much. All right. So next one is diphosphorus tetraoxide. So here we're looking for a metal. We have phosphorus and we have oxide or oxygen. Those are both nonmetals, so this is not an ionic compound. Also, the Greek prefixes are a dead giveaway that we have a covalent compound here. Remember, the Greek prefixes tell us how many of each element we have in our formula. So this actually tells us how to write the formula. So diphosphorus means I have 2 phosphorus atoms in my formula. So I'm going to say P2. And tetra is the Greek prefix for 4. So I have 4 oxygens. So I'm going to write O4. And that, ladies and gentlemen, is the formula for diphosphorus tetroxide. Now, you might be looking at this and say, well, wait a minute, Mr. Koval, why don't we reduce this? It's 2 to 4. Can we just reduce it to 1 to 2? And that would be a big no. The reason why is because this is not an ionic substance. We only want to reduce the subscripts for the ionic substances. So this is a covalent substance. So this is the formula for this substance. If we reduce this and change the formula, we no longer have this substance. This name goes with this formula and only that formula. Okay. So H, aluminum carbonate. Aluminum, obviously a metal. Carbonate is a polyatomic ion. So we have an ionic substance. So, we have Al. Aluminum has a 3+ charge. It's going to lose 3 electrons to be like its noble gas. And carbonate, you just have to know. So carbonate, excuse me. So we have CO3 2 minus. And so here we do the crisscross method. So the 2 for the carbonate is going to go down here. The 3 is going to go down there. So if you rewrite our formula, it's going to be Al2 CO3 3. And that is the formula for aluminum carbonate. And last but not least, we have sulfuric acid. Notice there's no hydro, so this is an oxyacid. So it's going to be a polyatomic ion with hydrogen added to it. So the polyatomic ion is SO4 because it ends in IC. That means that the ATE ending was dropped to be replaced by the IC. So we need to replace the ATE, and so we have sulfate. Notice that we have the extra UR there. So again, just like phosphorus, the naming, it's just different. Depends on what the substance is. But most of the time, you're dropping ATE and adding IC. But there are some exceptions as far as like what do you keep after. All right, so we're going to add this back. So this is going to become the sulfate ion. So we're going to have the sulfate ion written like this. So you know that the sulfate ion has a 2 negative charge. So if we're going to add hydrogen to this, thinking of hydrogen, oops. Sorry about that. So if we're thinking of adding hydrogen to this and adding hydrogen as H+, then we need to balance the charge. Again, this is not an ionic substance, but if it were, we would need 2 H pluses to balance the 2 minus here. So we would have to add 2 hydrogens like so. And so we can get rid of the charge, and that would be the formula of your sulfuric acid. And that, ladies and gentlemen, is how you do it. Thanks for joining me. I hope you enjoyed this video. If you did, then please like the video, share the video. Also, hit that like button. Make sure that you subscribe to my channel, and when you do, make sure that you hit that notification bell, and then click all so you can be notified by all the videos I put out. And then finally, put a comment down below. I would love to hear from you. Let me know what you think. Ask me questions. If there's a topic you want me to cover or a particular problem you want me to solve, then I would be happy to do that for you. Thanks for joining me, and have a great day.